In this short video, we take a closer look at how mathematical modeling can be understood in the context of mathematics education. Let's start with a short definition. Mathematical modeling is one of the central process-related competencies in mathematics education and is included in many school curricula worldwide. It is a process of solving a real-world problem using mathematical methods. This means that the focus is on the reciprocal translation processes between reality on the one hand and mathematics on the other hand. In mathematics instruction, modeling processes are initiated by so-called modeling tasks. The modeling process is often divided into sub-processes and ideally represented as a cycle. A modeling cycle that is widely used in school practice and mathematics education is the one by Blum and Leiss 2007, which you can see here. The modeling process starts with a real situation which is represented by a task. This task needs to be understood and transformed into an individual situation model. Next, simplification and structuring processes are carried out in order to create a real model. This real model is then mathematized to form a mathematical model. Now, mathematical work can be carried out, leading to mathematical results. These results need to be interpreted and transferred into real results. Finally, the results must be validated and presented, for example, in form of a concluding statement. To illustrate the modeling process, let's consider the following model example task. The Westhever lighthouse was built in 1906 at the German coast of the North Sea and is 41 meters high. The lighthouse should in former times inform ships which were approaching the coast about their position against the coastline. How far off the coast is a ship when the crew is able to see the light fire for the very first time over the horizon? Once we have understood the task, we need to make some assumptions and simplification in order to be able to complete the task successfully. First, we assume that the Earth is a perfect sphere with a radius about 6,370 kilometers. Furthermore, we assume that the light shines from the highest point of the lighthouse. That means at the height of 41 meters above sea level. We also assume that the crew on the ship are at sea level. When structuring the data, we notice that we do not need the year the lighthouse was built. With the help of a drawing, we can see that we can model the problem using a right-angled triangle. We can then apply Pythagoras theorem to obtain a mathematical result. This is about 22.85. We can then interpret this result in relation to the real situation by adding the unit of measurement kilometers. Then we can validate the result by conducting an internet research, for example. Finally, we can answer the question by formulating the following concluding statement. A ship at sea level can first see the light of the 31 meters high Westhever lighthouse from a distance of approximately 22.8 kilometers behind the horizon. At the end of the video, I have summarized the image credits and the references, and if you are looking for further reading, I can recommend the overview article by my boss Stanislav Shukayev. Otherwise, there's also a slightly new article by me. Among other things, it discussed how digital tools can help with modeling. You will find the links of both articles in the video description. Finally, I apologize for my poor English. As you notice or hear, I'm not a native speaker, but I hope you still find the video useful. Bye.